to the wild wonders of southern Africa, where you get swept away on a magical safari. A journey that takes you to places and animals very few have gone before. Subscribe and join the Wild Wanderer family today.
Hi there, grade 8s. I'm Mr. Lategan and I'm going to teach you a little bit more about molecules of elements. So in some previous lessons, you have learned about elements. What are they? Now, let me refresh your memory a little bit. You look at the periodic table, we have learned that elements are those atoms that basically are unique. There's only one of a kind. And this guy, Dmitri Mendeleev, long ago, he realized that each element can be classed according to their weight, and he made a periodic table of elements. So, today's lesson is all about molecules of elements. There's something that you need to understand, that two or more atoms, you guys have learned about atoms, right? That are joined together form a molecule. The atoms are held together as a molecule by means of a chemical bond. That's why this is called chemistry. We are busy with chemistry. So, two atoms of the same element bond together to form something called a diatomic molecule. Okay, so the word di almost sounds like bi, and it actually has its same origins. You can think of bicycle, meaning two wheels. Right. So, diatomic means two of the same. For instance, we can think of oxygen. Oxygen needs a friend. So, you need to understand, because these atoms are chemically unstable on their own, they occur in pairs. These pairs are called molecules of elements. So on the periodic table, guys, most of your atoms or most of your elements, when they are taken from the periodic table and we release them into nature, almost like a Pokeball, and we go, I set you free, they can be stable on their own. So, they're content being introverted. But there are 7 diatomic molecules that as soon as you take them from the periodic table and you release them into nature, they are going to be unstable. And remember, when we go back to the lesson about atoms, inside of the atoms we have your nucleus with your protons and your neutrons. These ones form your nucleus. On the outside of the atom, there are electrons that are negative and are spinning around constantly. If these are uneven and you release them out into nature, okay, they are definitely going to be unstable. They're going to search for a friend the whole time. So, these 7 diatomic molecules are the following. First one, it is nitrogen. And as soon as we take it from the periodic table and we write it on its own, we have to put a little number there. And that type of little number there, we refer to it as a subscript. Okay, so as soon as you see that, you know 2 atoms are chemically bonding together to form a molecule of nitrogen. Okay, the other 6 are hydrogen. See that I already wrote subscript 2. Then we have oxygen, and we also have fluorine, capital F, small case L. Then we have chloride, capital C, small l. Then we have iodine, And we also have bromine, Br2. Okay, so if we have a look at it, we know that there are 7: nitrogen, hydrogen, oxygen, fluoride, chloride, iodine, and bromine. These are the 7 diatomical molecules. Okay? We have 2 extras that don't fall under diatomical, but they can stand on their own. The first one is carbon. Carbon, as soon as we take it from the periodic table and release it out into nature, it is so stressed out, it is so erratic, it needs 5 other friends. 5 plus, this one makes 6. Okay, then lastly, we have sulfur. Sulfur is even more stressed out. It's such an extrovert, it cannot cope without 7 extra friends, so it is S8. Okay, to recap, if I want to put this into easy terms, let's use hydrogen. I can say the symbol for hydrogen is H. Okay, this is 1 atom. If I have a picture of it, this is what the atom would look like. So, symbol, written it out, 1 atom of hydrogen. If I have 2 atoms of hydrogen, see that 2 times hydrogen, okay, 2 atoms, it would be represented like this. Okay, now you need to remember this is still all on the periodic table. As soon as I take it from the periodic table, I've learned 7 diatomic molecules are formed. Hydrogen is definitely going to look for a friend. So 1 molecule of hydrogen, 1 molecule is going to look like this. Make it easy, let's put the symbol inside of the picture. That way you can understand it much easier. Now, if we look at this, this is just representing 1 molecule. If I want to see what 2 molecules looks like, I am definitely going to go, okay, this is 1 molecule, here's another 2 molecules of hydrogen. This 2 just refers to as the coefficient. Coefficient of 2 times hydrogen molecule is going to look like that. See? These 4 atoms of hydrogen are only chemically bonded twice. Does that make sense? Okay. Now, all of you have learned and heard somewhere about the following. You have learned that the molecule for water is H2O. Right? We've all heard that. Water is H2O. But what does it actually mean? Now you've learned that a subscript refers to the fact that 2 of them are chemically bonded. So 2 hydrogens bonded with 1 oxygen. Okay, so let's quickly equate how do we get that. We take oxygen from the periodic table and we take hydrogen from the periodic table, but as soon as we put them out into nature, we need to learn what are the molecules of elements. So oxygen is definitely there, we need to give it a subscript of 2. Hydrogen is definitely there, we need to give it a subscript of 2. This in chemistry, the arrow refers to equals in mathematics. So we know O2 plus H2 give me H2O. But is this a balanced chemical equation? No. I'll break it down. You will notice we have 2 oxygen atoms, and we have 2 hydrogen atoms on this side of the equation. On the other side of the equation, we have 1 oxygen atom, 2 hydrogen atoms. Now, what I can see here is hydrogen is balanced for now, but oxygen is not. 2 on this side, 1 on that side. So, for me to balance this, I need to make more molecules available. In order to do that, I'm going to look at oxygen. How many times do I need to times oxygen to get to 2? 1 times 2 gives me 2. Okay, so if I can't put the 2 here, that means it's a subscript that's going to chemically bond it. I don't want to. I want to have more molecules. I'm going to be putting a massive 2 in the front there. Remember, it's the coefficient times the whole molecule. So, I need to now check. 2 times 1 is 2. 2 times 2 is 4. Remember I said, for now hydrogen was balanced. Now it's no longer balanced. So, what I do on this side of the equation, I need to do on that side. So, to get 4, I need to times hydrogen on this side, also with 2, then I get 4. But I need to put a coefficient of 2 here. O2 plus 2H2 gives me 2H2O. But still, this looks a little bit complicated. Let me draw a picture to make it easy. On the left hand side, I am now left with oxygen, 1 oxygen molecule plus 2 hydrogen molecules you see, that's going to give me let's put the arrow here, 2 H2O molecules. So let's keep with the color scheme. Hydrogen like that. And now, do you see that the oxygen separates here and joins the hydrogen? This is the chemical equation for water. In nature, when oxygen and hydrogen combines, water molecules are chemically formed. Oxygen splits up and they can be stable enough with hydrogen. Okay, recap. There are 7 diatomical molecules of elements. On the periodic table, everything that you take from the periodic table, except for these 7, and carbon and sulfur, are content and stable when you release them out and you start doing experiments. These 7 plus carbon and sulfur are not content. They need friends. They crave bondings. Okay. So, hydrogen atom two hydrogen atoms, one hydrogen molecule, two hydrogen molecules. That is regarded as a coefficient, and that is regarded as a subscript. I hope you guys enjoyed today's video. If you did, give it a like, leave me a comment what else you are struggling with for natural science for the CAPS curriculum. See you guys next time. Bye for now.
Please subscribe to my dad's channel and also watch all of his other videos.